Thank you very much for visiting us, visiting Moscow, visiting Center for Consciousness Studies. Thank you, Dmitry, for invitation, and our philosophy faculty. Our first questions. In your famous book, Neurophilosophy, published in 1986, you says that in mid-70s you lost your patience with the most mainstream philosophy and turned to a new kind of philosophical methods. My question is, however, about your early philosophical interests. How did you come to philosophy after all? How did you come on early philosophical interests?
Yes, well, that's a very good question. But let me first say what a joy it is to be here and what a great honor. It's really a wonderful, wonderful thing. So my early interests, I think, really did have to do with the nature of the mind. As an undergraduate, I really wanted to understand the nature of perception and consciousness and how we learn and remember. And at that time, psychology was still very much within the behaviorist tradition. We hadn't yet had the sort of shift to cognitivism. And so it seemed to me that philosophy really offered the most promising route to answering those questions. I think the disappointment came when I realized that much of the philosophy that was being written at that time was really not about the phenomena. It was really about words. It was about concepts. And for me, the question was, okay, let's be clear about that, but as clear as we can be, but then let's find out about the nature of the phenomena itself. And so I think the thing that had a most striking effect on how I began to shift into neuroscience were the split brain results, where the two hemispheres in certain epileptic patients, the two hemispheres were separated. The deep connections remained, but the hemispheres were separated. And in a very straightforward sense, consciousness was split. And it seemed to me, and to the people who were doing that work, that this was really a kind of demonstration that consciousness was really a property, most likely, a property of the brain itself. And that if we wanted to understand our mental functions, we needed to understand the physical brain. So that was kind of how, that's a short story without all the stumbles. About how I came to
But why you decided to become a philosopher to begin with, even before university?
Well, I'm not sure that I did before university. I think I was just curious, like all children. And like all children, you know, you wonder about things like, I wonder if other people see colors the way I do. And I wonder, you know, what makes you change. Dmitry and I were talking about this last night. You know, you go through puberty, and before that, you know, I thought the boys were kind of smelly and stupid and not very interesting. And suddenly, you know, you're 12 and you think, why do I keep thinking about that guy? And I'd kind of like to be with him. And so you wonder about things like that. I thought actually in high school, because I grew up, as I think you know, in the country.
Yes.
And I thought I would go into law. I didn't know anything about philosophy. I'd never heard of it. So I thought I would go into law, but the more I learned about law, the less it was of course a very institutionalized structure. And I thought, I really do want to understand humans and animals and biology. And so I did have quite a lot of biology as an undergraduate as well.
So in a sense, you were a neurophilosopher from the beginning. And you famously criticize so-called armchair philosophy. But why armchair philosophy is so bad? And can you give us some examples of, as you say, perverse, dark, and anyhow pointless? That's your own armchair philosophy. Why is it so bad? And some examples of bad armchair philosophy.
I think the real worry with armchair philosophy was that people thought that simply by understanding as much as they could about the concept, that this would actually tell them something deep, something deeper than science could discover about the nature of the phenomenon. And I think that's misguided. That ultimately, if you want to understand the nature of knowledge, and the thing that produces knowledge and organizes information is the brain, then I don't quite see how thinking about the concept of knowledge can put real constraints on what science can discover. And so I think the general point is that some concepts need clarification just so we understand each other. But it's always an open question whether a concept actually applies to anything at all. So it might be necessarily true that a nervous breakdown causes a split in personality. But it might be that there is no such thing as a nervous breakdown. There are brain conditions of this kind and that kind and the other kind, but nothing really corresponds to that. In just the way that after we began to understand the nature of thermodynamics, we realized that you could be very clear about the concept of caloric, but it doesn't apply to anything. So I think that was one instance. Another instance was when philosophers, you wanted an example of where we were misled. Philosophers since Locke have really kind of assumed that if you lost your autobiographical memory, if you had no recollection of events in your past history, that you would lack a sense of self, that you would be just all discombobulated. It's not true. So there are several examples, living examples of people with brain damage. And I will talk about a patient that was studied by Antonio Damasio when I had the good fortune to meet this patient. And his name was Roger Boswell, and he has now passed away, and the family has agreed to allow use of his name. So I met Roger. Now, Roger has no autobiographical memory. The only thing he knows is that he was born in Iowa. He does not know whether he was married, which he was. He does not know whether he had children, which he does. He does not know what job he worked at. Now, what happened to Boswell? He was a very normal person. He was actually a car salesman, and a very good one. And he had a disease, an infectious disease that sometimes goes through the nose and into the brain called herpes simplex encephalitis. It causes a terrible inflammation of the brain. And as a result, on both sides of the brain, he lost hippocampal structures, the hippocampus itself, but also the related structures. So he lost all autobiographical memory, and he can't learn anything new. He can't find his way around the hospital, for example, even though he's been told many times. So does he have a sense of self? Yes. It's not, of course, the robust and rich sense of self that he had before his condition. But when you meet him, you would not know at first, for the first 10 seconds or 40 seconds, that there was anything wrong. He's very cordial. He's very gracious. How lovely to meet you. And he'll say something about your clothes because, of course, it's a present thing. And if you say to him, "So, Roger, how did you get here today?" He'll say, "Well, you know, it's hard to say." But it doesn't bother him that he can't remember. And you say, so Roger, did you play basketball when you were a boy growing up in Iowa? Oh, basketball, basketball. You know, it's hard to say. So he's very gracious. He's very composed. He knows when he's hungry. He walks and moves in a normal fashion. If he turns away from you to talk to somebody else, and then he turns back, he doesn't remember. He doesn't remember meeting you. He doesn't remember anything of the conversation. And yet, there is some real self there. Still, philosophers quote Locke and say it's part of the very meaning of the concept of self, that you must have an autobiographical memory to have a sense of self. And it's just empirically wrong. So that would be an example, but I think there are many that we could use. I think Jerry Fodor, for example, in analyzing the notion of representation and tying it closely, because of conceptual analysis, tying it closely to language, really steered psychology for a while, but certainly philosophy for a long time, in the wrong direction. We know that many animals, including human animals, have representations and do very complicated problem solving. They have spatial representations, for example. These are not linguistic. And I bet your spatial representations, by and large, are not linguistic.
Excellent, thank you.
So can you explain the neurophilosophy? Is this a kind of analytic philosophy at all or not? And what is its relationship to science?
That's a very fair question, and I suppose it's always a work in progress. And then in the hands of different people, it's going to mean different things. I think that for me initially, it just meant that neurophilosophy is at the interface of neuroscience and the grand old philosophical questions about the nature of knowledge, how we learn and remember, how we reason, how we problem solve, how we perceive things, expect things, and plan things. And my expectation was that developments in neuroscience were going to shed light on those. What I think I sort of share with traditional analytic philosophy is the need to be very rigorous and the need to be as clear always, whatever you're talking about, whether it's science or anything else, the need to be really clear. And also the need to change your mind when the data go against it. And so I, you know, in a certain sense, I suppose I share some aspects of traditional analytic philosophy, but not others. In the way that you might say other philosophers of science do. So when philosophers of science are interested in the nature of explanation, for example, they have a tendency to want both to be very clear, but also to draw on historical scientific examples of what count as good explanations. And that's kind of how I like to do it. What I don't like about some aspects of analytic philosophy is the idea that we can say what the boundaries of knowledge are, for example. And then whatever neuroscience does has to kind of live within those boundaries. Like knowledge is true, justified belief. Nobody but philosophers believe that. Because we know, for example, nobody does. Not people in the street, not scientists. You explain to them that's what philosophers they think. Now, what do they think? I mean, like, how do they think about a rat's knowledge of its spatial environment? Is that justified for the rat? Is that true for the rat? Well, the rat doesn't know. I mean, the rat uses the information to get itself around, to feed itself, to find its mates, and so forth. So it doesn't set limits. And so I think there is a kind of delusion among some philosophers that what they're doing is metaphysics, and it's deeper than science, and that science will be happy when science realizes that metaphysics is setting the limits.
So can you give examples of the most successful cases of how neuroscience illuminates the traditional philosophical discussion?
Well, I think there are many. At the moment, of course, I'm very interested in spatial knowledge, and that is because the structure we talked about with regard to Boswell, the hippocampus, has been really well studied in animals, in rodents in particular. And so we know some really, really striking things about spatial knowledge in animals, and that it's very rich. That if, for example, you have a rat and you put in, let's say, 50 electrodes into its hippocampus and you let it run around this wonderful space, that every time it's here, this cell will fire, and every time it's here, this cell will fire, and so forth. It tiles the whole space. And so it makes a map. So here we have an idea of representation that is much more map-like than it is language-like. And that's a very deep point. We also know about the rat, and of course, this is partly what got the Mosers and John O'Keefe the Nobel Prize, was this work. We know that when the rat has run a maze, let's suppose, and found that over there it always gets a nice bit of cheese, and now you let it rest, and the rat is resting. And you're listening to the activity of cells in its hippocampus. Here's what you hear. The rat is replaying its route through the maze. It's like it's imagining. Now, whether the rat's conscious or not, of course, I'm not really about to say. But the rat is rehearsing its spatial knowledge. And of course, we understand why that could be. That is why that would have evolved. Like, it's really handy to upgrade your knowledge and to consolidate your knowledge while you were up and about. We also know that during deep sleep they do that. So there goes the rat's asleep. And here's another interesting thing. There are very specific cells that respond to head position. This is true of us too. So every time the rat is pointed here, this cell fires. When it's pointed here, this cell fires, and so forth. So what happens when the rat's asleep? Well, let's say he's pointed here. And now we hear him running through the maze, and we realize that in his imagination, or in his rehearsal, his head is actually pointed that way. Not in reality, but in his rehearsal. And we can see that because those cells are firing. So I think that's huge. I think it gives us a line on how to think about knowledge that's not mysterious. It's kind of, there are many questions that remain, and I can talk about those too. But it gives us an idea that maybe our kind of knowledge is closer to that of our evolutionary ancestors, like rodents, than we might have imagined. That maybe even lots of our causal knowledge is more map-like, maybe in a 12-dimensional map. We know that the bat has a 3-dimensional spatial representation, whereas the rat may not. Anyway, so I think within neuroscience, it's given us a way to think about representing in nervous systems that is very much more biological, but that has not come out of any conceptual analysis. But it is a kind of theorizing. And I think philosophers belong under the tent where we can all theorize. But yeah, they have to be sensitive to the data. So that would be my favorite example.
Thank you. Now, a few questions on metaphysics of consciousness. Your views are often associated with so-called eliminative materialism. But are you really such a materialist? Do you believe that mental states don't exist, or rather you believe that they are identical with brain state? But then it's identity theory. What is the difference between identity theory and eliminative position?
Oh, I'm so glad you asked that. Okay. First of all, eliminative materialism is really just a prediction. It's a prediction that says as our folk psychology gets informed by neuroscience, we're going to start thinking about things in different ways. Now, Paul was really interested not in visual perception and goals and pains and so forth as objects of elimination. He's quite happy to think that those are likely to be very useful concepts within neuroscience. What he was concerned about were beliefs. And at the time that he wrote, beliefs were, in general in philosophy, held to be states of the brain identified by a piece of language. They were linguistic entities. And really, the hypothesis was very simple. It's that, first of all, neuroscience is going to change how we think. Who knows exactly how? But secondly, the idea that beliefs must be linguistic is going to crash because there are non-linguistic humans who can solve all kinds of problems, including babies, and because there are non-linguistic mammals that are not humans that can do these very complicated things. Now, for quite a while, it was standard in especially East Coast philosophy to say, no, those animals, it's just reflexes. They don't have beliefs. They are not really problem solving. It's all conditioning. And of course, we know now that's not true. It's not even remotely close to being true. So the eliminativism really was to say, some of our concepts are going to change. We don't know how, but probably the concept of belief is going to change. And this, of course, has been picked up by other neurophilosophers. And most famously, I think, by Chris Elias Smith, who has a conception of representation that is really couched within the framework of neuroscience that is very different and that is not tied to language. And that includes, of course, the spatial representations that we talked about earlier. We never thought that consciousness didn't exist. People sometimes, interestingly, you're one of the few people who realizes we didn't say that. And that's because you took the trouble to read. But a lot of people just assume, we must think consciousness doesn't exist. We actually thought that you could investigate the nature of consciousness by understanding the brain. And as I remarked at the beginning, a major motivation for thinking that were the split brain studies. And the fact that someone could be aware in his right hemisphere of one thing, aware in his left hemisphere of a different thing, surely suggests that there's something really important about the brain and consciousness.
So, what in ontological sense is, ask you about your current position, what is the mental image of, say, apple, green apple, in ontological? Is it a fine of a group of neurons or something else? What is?
Well, I mean, think about, let's not worry too much about the green apple for the moment. Let's think about the rat's spatial representation. When it's sitting there resting and it's rehearsing its route through space. What is the ontological status of that? It's probably the same in you and me, and the ontological status is that it's a state of the brain. When you are in that state of the brain, you may experience spatiality. When I'm looking at the state of the brain, I won't see the spatialness because I'm not having those neurons fire. So there is that difference, and it's the difference. So it's kind of like to think of the subjectivity as those neurons that in my brain yield that experience are activated. But of course, when you look at my neurons, they're not going to activate your neurons to have that experience.
And what exactly is experience? Is it the same as simply some processes? What is experience in your talk?
I guess I'm not really sure. I think we'll kind of have to wait and see how things develop. we can talk ourselves into thinking it's deeply mysterious, or we can talk ourselves into thinking, look, let's just kind of wait and see how things develop. It's like people who in the 13th century really didn't understand fire. What really is it? You know, and is it ontologically separate? Well, of course, lots of people thought that it was. They thought that fire is an element. And there's earth, air, fire, and water. And those are fundamental features of the universe. And it's like people, and I'm not saying that that was foolish. I'm saying it was a very natural thing to think at the time, because that's where science was. In our own lifetime, really up until the 50s, there were people who thought that livingness itself was a special force that was ontologically separate from all of the molecules that go to make up a cell. That you can assemble these dead molecules that make the membrane, that make the mitochondria, that make the DNA, but then you have to add that ontologically special thing, the livingness itself. And that turned out we just didn't know enough. And once we knew enough, we thought, okay, it looks different from how we thought. And my guess, but of course this is a prediction too, and I could be wrong. My guess is that it's likely to turn out that way for consciousness, because we know you can stimulate one very specific part of the brain, and it will cause you to have an out-of-body experience.
But there is a correlation, that's for sure. But why should we need to go to make another step and to say that it's identity or something else?
Sure. I think because we always want to go beyond correlation to causation. And so in the case, for example, let's say of these head direction cells that we know are in the rat, they're there and they seem to be there by birth. And what we want to know is how they got there and how they connect to the place cells that constitute the spatial map of a particular environment. So there's always in science this push to not just see a correlation between changes in DNA and changes in the liver, for example. We want to see not just a correlation, we want to know, how does that happen? What are the causal mechanisms?
But even causation is not identification.
No.
Effect is not cause, after all. It's different things.
Of course. But in the history of science, it seems that once you get a certain kind of fit in your data and in your causal story, then you often are able to make an identification. So you could say, for example, in thinking about thermodynamics, we now believe that temperature just is movement of molecules, right? Mean molecular kinetic energy. That seemed very surprising. And it seemed much more natural to think of it as caloric, to think of a fluid going from a hot thing to a cold thing and so forth. And so why did we say it was identical? Well, some people, you could still, if you wanted to, dig in your heels and say, oh no, temperature is a fundamental feature of the universe. It's correlated with mean molecular kinetic energy, but they're not identical. And if you say that to a physicist, they usually say, sit down and I'm going to explain to you why we do this. And if you think about light is identical to electromagnetic radiation, why did we do that? Lots of people thought, including Goethe, that light was a fundamental feature of the universe. We did it because of this absolutely stunning matchup between what we knew about light and what we knew about electromagnetic radiation as revealed through Maxwell's equations. The equations just sort of, hey, wait, it's not like we got two things here, guys. It's only one thing. That's a hypothesis. So once you have a hypothesis about identity, then you see how good it is. And that would be true in neuroscience. If we have a hypothesis about the distributed networks and their properties that have to be in place in order to be conscious, if we think that there is an identity, that's not the end of it. Then we got to test it. We got to see how good that is. And if it's not very good, start over.
Thank you.
In one of your papers co-authored with Ramachandran, it's called
right.
The Filling In Why Dennett is Wrong. You suggest that some of the hypotheses entertained in Consciousness Explained are contrary to empirical data. In particular, this is the hypothesis about the filling in. So can you explain a little bit more about the argument and the data? And also, do you think that this actually undermines the core of the multiple drafts theory?
Well, there are quite a few questions there. Rama and I were very interested in the claims about filling in Consciousness Explained. And the fundamental idea was that the brain doesn't actually fill in anything. It's just that we infer that something happened on the basis of other things we believe, but there is no literal filling in the brain. Now, Rama was long interested in neuroscience, but he also was a very accomplished visual psychologist. And so the first thing that we wanted to ask was, is there any neurobiological evidence that there is, in the visual case, actual filling in? Is it the case, for example, in illusory motion, so-called, that when a light goes off here and comes on here, and you see movement, if you record from cells in a movement-sensitive area of visual cortex, what do you see? And the answer is, you see those cells respond in exactly the same way that they do when there's real visual motion. Similarly with seeing green. So there are these wonderful psychological setups where it looks like there's a green patch in an intersection. And you think, there is no green in the stimulus, and I can be sure of that. So is there anywhere in the brain that is responding as though there were a green stimulus? And the answer is there is. And so we challenge the idea that the brain doesn't fill in. We think that even in very early stages of visual cortex, the brain is doing a lot of kind of constructing, and this is what Andy Clark would say. The brain is organizing the data so as to make the best prediction about what's going to happen next. And hence, filling in is actually a good thing to do. And once you think about it that way, and then you go into the literature in psychology, whether it's on the auditory system, but particularly in the visual system, you see it everywhere. There's auditory filling in, and there's visual filling in, and some of these are expectation effects and so forth. But and sometimes we may make an inference. Like I might make an inference about what you're going to say next, but that might not be filling in. But other cases where psychologists have tested and tested and tested, it's very clear that actually the brain is doing some filling in. So then the second question is, what's the implication for multiple drafts? And my own feeling was at the time that I didn't really understand from within a neurobiological framework what this could mean. I mean, Dan talks about competition, and he talks about it. Neurobiologically, I couldn't really get what the idea was. It was kind of a fetching metaphor, but I couldn't really see what this metaphor was doing. Now, of course, we've known since Helmholtz in the 19th century that there's lots and lots of non-conscious information. But the idea that there are competing stories about what's out there, and that a whole lot of the non-conscious processing has to do with competition between these stories. There's no evidence for it that I know of. So I think that it isn't a particularly compelling story. I mean, maybe in the fullness of time it will fill itself out. Maybe it will fill itself out to give us a more complete story. But you know, the thing is that we have within neuroscience some really interesting data about the difference between being in deep sleep and being awake, the difference in the brain itself, and between sleeping and being awake in the brain. And we have data from anesthesiology that shows something about what really happens and why we lose consciousness when we're given an anesthetic like propofol. And I don't quite see how any of these stories, you know, kind of fit in with this consciousness explained but not really story that Dan Dennett suggested. So it didn't seem to me to kind of further our understanding in a way that made sense to me. But I think other people found it more compelling than I did.
Now to moral philosophy. So it's often assumed that responsible action is actually an action controlled by the agent.
Yeah.
So do you agree with that? And if so, what are the main neurological differences between the controlled and uncontrolled action?
Brilliant question. So responsibility is really a notion that lives in the social world. We care about responsibility because we are social animals that live together, and sometimes we have to punish. Sometimes we have to remove people. We also care about it because as children develop, we want them to develop self-control, and we know that that development is a causal process. You can't have self-control without the causal process that involves the development of that circuitry. Now, as to what we know about the neurobiology of self-control, let me qualify it by saying there's much we don't know, especially at the circuit level. So we know that frontal structures are important, but they are also strongly connected to the basal ganglia, to these subcortical structures. And the basal ganglia, interestingly, are the structures that are sensitive to or that implement reward learning, reinforcement learning. And so not surprisingly, a large part of acquiring the robust circuitry for self-control involves tuning up the reinforcement learning system. So you get approval for certain things, disapproval for other things. There's trial and there's error. There's reward and there's punishment. And in ways we don't entirely understand in neuroscience, this connectivity between the basal ganglia, and that includes reward structures like the nucleus accumbens and the amygdala, the connectivity between all of those lower deep structures and cortex is clearly important. Mm-hmm. We also know, it's kind of interesting, this is again from rat studies, but so neuroscientists have had to ask themselves, so what exactly do we mean by self-control? And so they said, well, look, let's just start with a simple set of behaviors. Let's say that you demonstrate self-control if you can defer gratification, or if you can cancel an action. So you're about to wheel into a parking space, but suddenly a kid chases a ball, you can stop. Cancellation of action, that shows self-control. Suppression of social impulses that are inappropriate, and all animals do this, or certainly all mammals do this. So they said, well, let's see if we can figure out tests. And they're very good tests for the capacity to defer gratification. So here's one test. So the animal is, the rat's put into a space, and he has to come along and give a nose poke, and then he gets a pellet. That's easy. Any rat can do that in no time flat. And then you put in another food tower. And now, if the rat nose pokes that one, it gets 5 pellets. Well, that's even better. Now, here comes the demonstration. So you say, okay, let's introduce a delay between when the rat nose pokes and when the pellets come. Can it wait, or will it go to here? And the answer is that many rats can wait, and they can wait many seconds. They nose poke and they sort of say, and they know if they go back to here, they'll get one, and then they're done. And some rats can't. So you introduce a delay of, say, 4 seconds, and he pokes and he goes over here, and they can't do it. And some you can show with action cancellation, a similar thing. So the rat nose pokes, it gets a pellet. But if it hears a sound here, it knows it has to cancel. Otherwise, if it nose pokes, it gets nothing. So the question is, how close can rats get to here before they can't stop anymore? And the answer is some can get really close and some can't. And here's the interesting thing. The circuitry for those two is somewhat different, as obtains between frontal structures and basal ganglia. They're shared circuitry, but they're somewhat different. So there's a big, big research program into understanding self-control. And as you know, it matters terribly to all of us and to our children and so forth, that self-control is robust.
But would you, given that experiment, would you say or suggest that the rats that cannot go to the and wait have no moral, have no responsibility, and the ones that can wait actually do have responsibility?
Well, it's a very interesting question. So now we're in the domain of responsibility. And now, in a way, I think this is where neurolaw becomes very interesting, because the people who are interested in neurolaw say, look, the law, the criminal law, and the assignment of responsibility is fundamentally resting on notions of public safety and public consideration. And so what the criminal law in essentially all jurisdictions wants to do is to remove people who are extremely dangerous, who pose a threat to the stability and the prosperity of the others, and to deter others from doing anything similar. So in the context of humans, we have really 3 parts to the criminal law. There's the sentencing phase that presumes that you were convicted, but then there is the convicting or finding guilty or not guilty. But even before that, there is the competency phase. And a person is considered competent to stand trial if they can help their lawyer in their defense. But if, as in one case I saw, the person is totally delusional, I mean, he really actually had lost a whole lot of his frontal cortex through alcoholism. He always thought he was at a hockey game. So his lawyer is trying to discuss with him these charges, and the lawyer will say, well, where do you think you are? And he'll say, I'm at the hockey game. And then he can't stand trial because he's not competent. But you don't say, well, then go off home, because this person commits violent acts. So you put him in custodial care. Mm-hmm. So responsibility is very, I think we have a really detailed understanding of the practical aspects of it when we look at the criminal law. Mm-hmm. And sometimes, for example, in the sentencing phase, the fact that someone was overcome with emotion and lost control, that's taken into consideration. Mm-hmm. People, the way the criminal law sometimes works, at least in America, is to say, would any reasonable person have done what he did? And if any reasonable person would have, that's taken into consideration in the sentencing phase, usually by dropping the sentence. Mm-hmm. So I think responsibility depends on many things. And if a person shows a complete lack of self-control, then But actually, nobody really does unless they're completely demented. Because everybody has some control. They have at least control over their bodily functions. And by and large, even in demented patients, you see that their social control is very deep and is there almost until the end. Even when they can't recognize their family, they are still polite.
What about psychopaths? Do you think that psychopaths are fully, morally responsible people?
Well, I think, we're learning a bit more about psychopaths, but I think it's still very puzzling about what's really going on, because some people who, on the basis of brain scan activity, are identified as psychopaths are perfectly normal. So it's a bit dodgy. We don't really, a lot more data have to come in. On the other hand, for some people who it's very clear that they have no compassion, they don't care, and so on, typically, as I understand it, they have had a very abusive and neglective childhood. Mm-hmm. Now, we know from rat studies that if the baby rats are removed from the mother, if they don't get the love and the nurturing and so forth, that even if they're fed and kept warm, they grow up with social abnormalities. The females, for example, don't make good mothers. They don't lick and care for their young, they kind of neglect them and so forth. So it may be that the most interesting part of the story about psychopaths is that there is a link to childhood and a link to the importance in all mammals of early nurturing, early love, early stability, and so forth. And in a sense, that's not surprising. I mean, I bet your grandmother told you things like that. She'd say, so-and-so neglects and abuses their kids, and their kids are not going to grow up properly. And she was right. They probably don't.
So, do you think that you can derive art as values from facts and
Right.
morality from the discoveries of the neuroscience?
Not really. However,
Okay.
here's an interesting thing. I think this is kind of funny. So all animals that have a nervous system have the circuitry to value self-survival. Right? The value of one's own self is embodied in the actual circuitry. We have no trouble with that. We don't have any trouble thinking that there must be a big fact value distinction here. The circuitry actually embodies the value of self-care, self-consideration, self-survival. And I think something like that is also true for social mammals in general, including humans, and that is the circuitry is there for valuing sociality. Now, the specific form that takes, the specific norms that come about in a society is a different question. Many of the norms we see across social groups, some norms are different. And there are some kinds of questions that are so dependent on our particular, very sophisticated social way of living that they could not have arisen for our ancestors. So questions about contraception, or questions about whether or not you should use the new CRISPR technology to edit genes that are germ cells. Well, that couldn't have arisen for Aristotle. I mean, and even if you'd asked him about, should we use CRISPR to edit germ cells? I mean, he isn't going to know what to say. So those kinds of norms we have to get together and figure out. But what underlies all that, and what is the platform for all that, is the fact that we have this sense of caring for others. In the first analysis, of course, the most strongest kind of caring is within family and with mates, and then kin, and then friends. And there's, again, wonderful rat studies showing some interesting things about altruism in rats.
Well, let's let's try to solve some moral dilemmas with neuroscience. So I'll give you a standard moral dilemma. So for instance, let's take the dilemma of lifeboat. So 30 survivors are crowded in a lifeboat intended for 7 people. And if all the survivors rest in the boat, all die. Mm-hmm. So what should we do? Can we approach this with the knowledge of neuroscience?
No.
Can we approach the solution to that?
No, I don't think neuroscience has anything to tell us about something like that. And I think here Sam Harris is just naive.
Okay.
It's just always more complicated than that. Mm-hmm. And if, for example, the details matter because moral reasoning is case-based reasoning. It's analogical reasoning from cases with which you're familiar. So what actually happens in these kinds of situations, we know, is that some very old people are apt to decide, hey, I'm past it anyway, and they'll kill themselves. They jump off the boat, and so forth. So these kinds of details hugely matter. And interestingly, in some of the experiments that have been done on trolleys and lifeboats and so forth, students, if they're not instructed, they'll say, yeah, but what if the person you're going to sacrifice is a great musician, or what if it's Mahatma Gandhi, or what if it's Nelson Mandela? They're thrown out of the experiment. Mm-hmm. So, but these details matter. If it is 1975 and I'm in a lifeboat and one of the people is Nelson Mandela, I might have a pretty good idea that no matter what happens, this guy needs to be saved. So the details hugely matter, and the actual psychological studies of how people make these kinds of decisions reveal that all of these complexities roll in. And philosophers who think that they can answer these questions in these very stripped down cases are fooling themselves. That's not how it works. Which just kind of means that morality and our social life is just astonishingly complex. Astonishingly complex. And I would never presume to think that neuroscience can weigh in and say, flat tax is better than graduated income tax. Really? Neuroscience? Yeah.
So, in the brain trust, you addressed the naturalistic fallacy.
Yeah.
So, the criticism of derivation of ought from is. In particular, you demonstrate that Moore's argument against derivation is based on the logical error. But there are other ways to make the point. For instance, one can point out that moral values, like good, are perspectival, good in relation to some goals. So, but facts are objective. What would you say?
Well, I think that of course, the way humans reason about what to do and what's valuable is certainly often based on their goals and other considerations. But bear in mind, what I was talking about at the beginning, and that is that there are certain fundamental things that is just built into the circuitry that we value. And we know why. If an organism lacks the circuitry for self-value, it's going to be somebody's dinner. It will not survive and reproduce. And so we know that Darwinian evolution really constrains the kinds of individuals that will survive and reproduce. And so if value, self-value, self-survival can actually be embodied in the very, physical structure of the nervous system, that seems to me to just put more, say, okay, very nice, that was lovely story you told us, now we're going to get on with it. Mm-hmm. Yeah. It's not there, this was, in the early part of the 20th century, and he had no idea about what really is there. And it's part of the social that sociality is part of the very structure of the way that mammals are. That circuitry produces pleasure when we are with those that we love. It produces pain when we're separated. And so we are motivated as a result of this circuitry to do things for those that we love. And if that isn't value, then I don't know what is.
Some personal questions.
Oh.
Yeah. So it is often said that your position is very close to the position of your husband, Paul. And even the criticisms of your and your husband's work have been assembled in the volume was the title "The Churchlands and Their Critics." It is interesting to learn where you disagree with Paul, and what are the most important points of tension.
Yeah, people sometimes ask that, and I'm not very good at finding those out. I mean, early on in our relationship, before we were married, I really had taken on board Quine's argument that there is no useful or productive distinction between analytic and synthetic sentences, that you can always hoax something up, but there's no meaningful and he disagreed. And so we were in Oxford at the time. I was still a graduate student, and we argued for about 2 weeks. But it was fun. I mean, it was always fun with Paul because he never got impatient or whatever. I mean, he was just, and eventually he came around. And I think the first time he talked to me about the idea of thinking about our explanatory mental concepts as kind of loosely speaking forming a theory that could in time be replaced, I said, oh, no, you got to be wrong about that. And we were driving across Canada, and it took us 4 days, and we argued the whole of the 4 days. But by the time we got to Vancouver, I thought, actually, I see your point. But, we do talk all the time. And I think because we disagree in a very congenial way, that it means that it kind of sharpens us up, so that when I get very sharp, sometimes mean questions from philosophers, I'm not too surprised. It's not like, oh my God, I never thought of that. Usually, he's come up with it. And so we've had a lot of fun.
Mm-hmm. Do you remember how did you invent the term neurophilosophy?
Yeah, I don't really. I don't, except that, I was learning everything I could about neuroscience at the University of Manitoba Medical School. And one of the great things that happened was that the neurologists invited me to come to their seminars and see patients and so forth. And, although I really, really like looking at detailed experiments with single cells, there's something about seeing human patients with very specific kinds of brain damage that just blows your socks off. So it had a huge effect on me. And one of the first patients I saw was himself a neurosurgeon. And he had a lesion in the brainstem fairly high up near the periaqueductal gray. And the result of it was that every once in a while, especially if he was slightly in a tense situation, he would begin to cry in the most heartrending way. And he'd say through this sobbing, I don't feel bad. This is just my brain. Woo! And then when it would stop, it was kind of like an automatism, and I guess that is what it is. When it would stop, he would say, to the medical students, I want you to understand that it was just a behavior. I did not feel bad at all for any part of this. I couldn't stop thinking about this. I went home, and Paul and I talked about it. How is this possible? I mean, the behaviors can't be right. You could have all of this physical behavior, and the feeling wasn't there. So anyway, I think I talked to the neurosurgeons and the neurologists, and I talked to the head of the lab I was in, Larry Jordan, and when it came time to kind of put these ideas together in a book, I thought about various things. Paul and I would sit in a hot tub in California, and we'd talk about what could be a good title for this. And an MIT press was very helpful in it, and I suggested neurophilosophy one day in the hot tub, and MIT loved it. MIT loved it. They said, don't change it. Go with it. Go with it. So that's
So it was like an insight.
I guess, but you know, stuff comes all the time, right?
Okay, but now to these days, to your current research projects, you have already said many interesting things about your current research. Maybe you can give us some more details and tell us something, please, about your future books. Maybe.
My future book. Well, you know, I'm kind of winding it down. But I mean, of course, there are many, many parts of social neuroscience that really interest me. As I indicated earlier, we know that there is this kind of basic platform in the mammalian brain and in the bird brain for sociality. But there's so much we don't understand about how that works. So I'm extremely interested in that. We know that it involves this simple peptide, oxytocin, but that's only a tiny part of the story. And I have been involved in some rather technical aspects of oxytocin, like how specifically to measure it. Does any oxytocin get in the brain when you spray it up the nose and so forth? And so I've been involved in that. But I'm also very interested in attention and the relation between attentional mechanisms and consciousness, and about what actually changes in the brain when there is attention. So those things really interest me. And then, you know, in the neurology is still endlessly fascinating. Nicholas Schiff is a neurologist in New York who sees patients who have had some sort of brain trauma, as a result of which they may be in coma or vegetative state or locked-in syndrome and so on. And the result, this is a very fast account of it, but one result is that there is a structure within the thalamus, which is kind of a brain within a brain, if you like. And that structure seems extremely important for regulating sleep-wake cycles. And it seems that if that structure is amiss, then everything else can be quite normal, but the person can be comatose. And he has two cases where they put in an electrode into the intralaminar nuclei of the thalamus. And the person, everything else in the brain looked normal. So they stimulated it and the person woke up. So we think now that, yes, brainstem structures are critical, the intralaminar nuclei are critical. There are other things that are important for sort of background consciousness, and then something like Stan DeHaen's story about, so then the content of consciousness depends on specific regions that get activated.
Interesting.
And now probably a very traditional question. We every time we have a guest, we ask this very general and personal question about the meaning of life. So what do you think is the meaning of life?
Oh, no, I think it's a
last
wonderful question. Yeah, no, I mean, of course, I don't think there's a terribly deep answer. I mean, I think it's kind of the answer that you would have got from Confucius, from Aristotle, you know, from the Buddha. And that is that family and friends, love and meaningful work, we know those things are really, really important to a meaningful life. And also, I think having the good fortune to not have some terrible brain condition. one of the things that does really haunt me, I think, are the neurological patients. There's something like 600 neurological conditions, for none of which do we have a cure, and for almost none do we understand. And the thing about, being paralyzed in the leg, that can be bad. The thing about, being partially blind or totally blind, that can be bad. But these neurological conditions impose a kind of suffering that is just beyond dreadful. And that really is, I think, a motivation for many neuroscientists to try to understand what's going on.
Well,
thank you very much.
Thank you very much.
Thank you. My God, you guys really did your homework. Oftentimes I get interviewed and people, they don't really know anything. And you guys...
But we professional philosophers.
Well, yeah, but even professional philosophers can interview me and haven't done the reading. So that's very nice. I mean, really, I am very impressed. It gives me a chance to address things in a concrete way. So I'm very grateful.
Thank you.
Well, thank you, Patricia.
Yeah,
Thank you.
fantastic.